Last week we talked about similar polygons and what makes them similar, and it's that all of the sides are proportional and that all of the angles are the same. So we're going to take that a step farther with triangles, and we're going to talk about ways to prove triangles are similar without having to prove all of the sides and all of the angles are congruent. So all the sides being proportional and all the angles being congruent. So there's a couple different ways we can do that. The first one is angle-angle similarity, okay? And you only have to have two angles because what we know about triangles is if we know two angles are the same, we know the third one's going to be the same as well. Okay, so if two of the angles in the triangles are congruent, that means they're similar. We automatically know that third one is going to be congruent as well, but we don't need that to prove similarity. We just need two of them. Okay, another way we can do it is with side angle side similarity. So just like when we were proving congruence, it's a side and then the next angle and then the next side. Okay, and the angles have to be congruent, but the sides have to be proportional, which means that if 15 over 10 simplifies to 3 over 2, then 12 over 8 also has to simplify to that exact same similarity ratio. So those have to be the same. And this angle here has to be congruent. And it has to be the angle that's in between the two sides that are proportional. The last way is if all the sides are proportional. So if all the sides are proportional and all simplify to the same similarity ratio, then the triangles are similar. So you can check that by saying, okay, 4 over 2, that's 2 over 1, 6 over 3, 2 over 1, and 9 over 4.5 also simplifies to 2 over 1. Okay, so they have the same similarity ratio on all three sides, so that's side-side-side similarity. Okay, so looking at these triangles, we're going to talk about the ways you can prove they're similar. So this first set of triangles here, SRT and PNQ, we're going to look at this and say, oh, I have two sides labeled on both and the angle in between I know is the same. So I think I'm going to use side angle side similarity. So I could do that by saying 24 over 18 and know that those are both divisible by 6. So 4/3. And then 28 over 21, both divisible by 7, also 4/3. So this right here, these two triangles are similar by side angle side similarity. Okay? You see here that I have two triangles, XZW, so XZW, so this one over here, and YZX. And I see that I have all three sides labeled on both. They share a side in common, but it's not the corresponding side. Okay, so we're going to look at this and say, okay, what's the longest side? So on this triangle, XZW, it's going to be 20. And on this one here, YZX, it's going to be 15, so 20 over 15. And then the middle side is 16 on the bigger one, 12 on the smaller one. And then the smallest side, so 12 over 9. And we want to show this is similar by side-side-side similarity. And so we're going to simplify all of these. So this simplifies to 4 over 3. This simplifies to 4 over 3. And this also simplifies to 4 over 3. So since all three of those are the same, this is side-side-side similarity. Okay? Now we're asked to determine whether the triangles are similar. So, and if so, we're going to write a similarity statement. So what I'm going to do is I'm just going to look. I see only angles are here. Sorry guys, bells are ringing even though you're not here. So first thing I'm going to do is figure out the missing angles in both of these. So I'm going to say 180 minus 26 minus 90. So I know this one is 64. Okay, and then if I do 180 minus 90 minus 64, and then I get that this is 26. Now I have all three angles being similar, but I don't need all three. It's just angle-angle similarity. And so the similarity statement would be that triangle EDC is similar to triangle, and I want to start with the 64-degree angle because that's where E was, and so H is that, and then G, okay. So that's my similarity statement, and I know that because of angle-angle similarity. Okay, again, we just want to show that these are congruent, or I'm sorry, that they're similar. And so the first thing is I'm going to point out that ABE, the smaller triangle, has this 52, and then angle A is a part of it. And then if you look at ACD, this bigger triangle, angle A is also a part of it. So we can say they're similar by angle-angle similarity, because angle A is a part of both. So even though we don't know the measure, we do know it's congruent because it's the exact same angle in both of them. Okay, first thing I notice over here on part B, to try and prove this smaller, SVR and UVT is similar, I notice these are vertical angles. I also notice that this angle T, since these are parallel, is congruent to angle R because they're alternate interior, and I can stop right there and say also that this is angle-angle similarity. If I wanted to prove that third angle, I could say that angle U is congruent to angle S because also of alternate interior angles. So it doesn't matter which two I pick to use, I just have to show and be able to explain why. Okay, these are all similar here. Or these are similar because they're all the same. Sorry, all the angles are the same. So we're going to write a similarity statement, and we know it's angle-angle similarity because all the angles are the same. So we're going to say triangle FGH is similar to triangle RQS. Okay, and then over here we have CDF and DEF. Okay, and so again I can do 180 minus 90 minus 32 and get that this is 58 degrees and that this one is 32 using the same reasoning here, and so we know it's angle-angle similarity again. And so I'm going to write a similarity statement that says CDF is similar to triangle DEF. And we know that because of angle-angle similarity. Okay, so here we're going to look here and decide which triangles are similar and write a similarity statement. So the way we can do this is we only have the sides. So I'm just going to go with the shortest sides first and compare. And so I'm going to start with this one here, LMN, and I'm going to say, okay, 20 is the shortest. And on this one, RST, 24 is the shortest. I'm going to say, okay, 20 over 24. So those are both divisible by 4, so 5/6. And so let's try and see if all of them have that same ratio. So 24 over 30 is the next one. So it's divisible by 6, and so it goes in there 4 times, in there 5. Okay, so I know it's not going to be these two triangles, okay, because these are not the same. So immediately I know it's not the first two triangles there. Okay, I'm going to look here and I'm going to say, well, I also notice that the shapes of these look a little different. So I'm just going to take a stab at it and see what happens. I'm going to try this one here, this one, and this one, okay, to see if they all have the same similarity ratio. So shortest side on the big one is 30 over 24 on RST. And so that's going to be divisible by 6. So 5/4. Okay, next one is 36 here. And this one is 30. Also divisible by 6. So 6 is 6/5. Okay, so it's not those two. So let's try these last two and see what we can come up with. So I'm going to start with the shortest side, and I'm going to say, okay, 20 over 30 equals 2/3. Okay, next biggest is 24 over 36. 12 goes into both of those, 2/3. And then 26 over 39. 13 goes into both of those, also 2/3. So I know that it's this first triangle here that's similar to this triangle here. And it's because they have the same similarity ratio between all their sides. So now I need to write a similarity statement. And I have to pay attention to the order. So I'm going to go triangle L, M, N. And I listed that because that's the sides from smallest to largest. So I know to go do the same thing here. So it's similar to triangle Y, Z, X. by side, side, side similarity. Okay? So now we're saying the shortest side of a triangle RST, or the shortest side of a triangle similar to RST is 12 units long. Find the lengths of the other two sides. So the shortest side on RST is 24. So I have, okay, so triangle RST is 12 units long. So we have triangle, we have this triangle, we know the shortest side is 12, and it's similar to RST, which on RST we know the shortest side is 24. So we're going to say 24 over 12 to get that similarity ratio. So we know it's 2 to 1. So then we can use that to find these other two side lengths. Okay, so we know that the next side of RST is 30. So we can say 30 over x equals 2 over 1. So just like we were doing last week, so 2x equals 30 and solve it. So we know the next side of that triangle is 15. And then we can do one more. I'll extend my page a little here. And oops, I need to know how long. So 33 is the longest side. So 33 over x equals 2 over 1. Cross multiply and get 2x equals 33. And get x is equal to 16.5. So we know this other side is 16.5. Okay? So we're just using that similarity ratio. Okay, so again, we're using our similarity and what we know. And so AB, right here, I see that that's got a whole number there in DE. So I'm going to use that to set up my similarity ratio, and I'm going to simplify. So 1/3. Okay, so then I can use that to find my other values of x. And I can use either side. So I could use this one or this one. I like this one a little bit better. It just looks simpler to me. So I'm going to use these two sides, BC and EF. So I'm going to say 1/3 equals x minus 1 over 18. So I'm going to cross multiply. 18 equals 3 times x minus 1. So 18 equals 3x minus 3. And so 21 equals 3x, and so x equals 7, and so we know that x equals 7. And that should also be what you get if you used these two sides to solve for the missing piece. Okay, these are probably familiar to you. It says Jenny places a mirror 24 feet from the base of a flagpole. When she stands 3 feet from the mirror, she can see the top of the flagpole reflected in it. If her eyes are 5 feet above the ground, how tall is the flagpole? Okay. Actually, I'm just going to make a game time decision here. We're going to skip this one. I think this one's a little bit more relevant, and this one's going to be more like the problems you'll see. I don't like the wording of that one. It is on your notes, though, if you want to look at it. So, when a 6-foot man, so here's my 6-foot man, he casts a shadow that's 18 feet long. It's not a very accurate drawing. A nearby tree casts a shadow that's 93 feet long, and we want to know how tall this tree is. Okay, so we can use this, and we would put, set up a proportion and say that 6 over x, because those are the heights of the actual things. And then we'll say 18 over 93, because those are the shadows, and so you want the corresponding parts together. So you're going to cross multiply and get 18x equals 558. Divide them both by 18, and you would get that the tree is 31 feet tall. Okay, and we're just using that we know that if the shadows are proportional and the heights are proportional, because the sun is shining the same direction on both of those. Okay, definitely look over the 8.2 and 8.3 notes. Let me know if you have questions, and that's all I've got for you today.